Installing a 100 amp panel board 200 feet from an existing 200 amp panel with the stucco finish requires careful planning to keep the conduit tight to the stucco, especially when using number 2 wire. Here are 2 methods you can use. Firstly, let's discuss the materials. You'll need 1.5-inch polyvinyl chloride Schedule 80 or Schedule 40 conduit, a 1.5-inch polyvinyl chloride sweep fitting, polyvinyl chloride glue, and electrical tape. Method 1 involves using an offset angle. 1. Install the conduit stub on the bottom of the existing panel, ensuring it is angled slightly away from the wall. 2. Connect a 1.5-inch polyvinyl chloride sweep fitting to the stub. 3. Run the conduit along the wall, parallel to the stucco, but slightly offset to the side. 4. Angle the conduit slightly back towards the existing panel as you approach the 100 amp panel. 5. Connect the conduit to the 100 amp panel using another sweep fitting. Method 2 utilizes an angled conduit body. 1. Install a 1.5-inch polyvinyl chloride angled conduit body on the bottom of the existing panel. 2. Connect a short piece of conduit to the angled conduit body. 3. Install a 1.5-inch polyvinyl chloride sweep fitting to the short piece of conduit. 4. Run the conduit along the wall, parallel to the stucco, as with method 1. 5. Connect the conduit to the 100 amp panel as before. Here are some tips to consider. Use a conduit bender to create the necessary angles. This will help you achieve a neat and professional look while maintaining the necessary clearances. Secure the conduit to the wall using conduit clips or straps. This will prevent the conduit from sagging or moving over time. Apply plenty of polyvinyl chloride glue to all connections. This will ensure a watertight seal and prevent the conduit from separating. Wrap the connections with electrical tape to provide additional support. This will help to protect the connections from damage and prevent them from coming loose. Run multiple feeds of number 2 wire through the conduit to allow for future expansion. This will give you the flexibility to add more circuits in the future without having to run new conduit. If the stucco is particularly thick, you may need to use a hammer drill to create a larger hole for the conduit stub. This will ensure that the conduit stub fits properly and does not damage the stucco. When working with number 2 wire, it's important to follow all safety precautions. Always disconnect the power before working on any electrical components. Wear appropriate personal protective equipment such as gloves and safety glasses. And be sure to consult with a qualified electrician if you have any questions or concerns. When selecting polyvinyl chloride conduit, you have 2 options: Schedule 40 and Schedule 80. Schedule 40 is the more common and less expensive option, but Schedule 80 is thicker and more durable. If the conduit will be exposed to physical damage, Schedule 80 is the better choice. When using polyvinyl chloride sweep fittings, be sure to select the correct size and angle. The sweep fitting should be large enough to accommodate the number 2 wire without damaging it, and the angle should be appropriate for the direction in which you need to run the conduit. When applying polyvinyl chloride glue, be sure to clean the surfaces of the conduit and fitting thoroughly before applying the glue. Use a polyvinyl chloride primer to prepare the surfaces for gluing. Apply a generous amount of glue to both surfaces and then quickly join them together. Hold the pieces together for several seconds until the glue has set. When wrapping the connections with electrical tape, be sure to use high-quality electrical tape that is rated for outdoor use. Wrap the tape tightly around the connection, overlapping each layer by at least 50%. This will help to create a watertight seal and prevent the connection from coming loose. When running multiple feeds of number 2 wire, be sure to use the correct size conduit for the number of wires you are running. The National Electrical Code, or NEC, specifies the maximum number of wires that can be run in a conduit of a given size. Consult the NEC for more information. When using a hammer drill to create a larger hole for the conduit stub, be sure to use a drill bit that is specifically designed for drilling through stucco. Use a slow speed and apply gentle pressure to avoid damaging the stucco. When working with electricity, it's always important to be safe. Follow all safety precautions and consult with a qualified electrician if you have any questions or concerns. By following these tips, you can successfully install a 100 amp panel bore 200 feet from an existing 200 amp panel with a stucco finish while keeping the conduit tied to the stucco. Remember to consider the aesthetic impact of your installation, especially since the panel is visible from a walkway. Keeping the polyvinyl chloride conduit tight to the stucco helps maintain a clean and professional appearance. Take your time and plan each step carefully to ensure a safe and visually appealing installation. One crucial aspect of any electrical installation is ensuring compliance with local electrical codes and regulations. These codes are in place to protect people and property from electrical hazards. Before starting your project, familiarize yourself with the relevant codes in your area. This may involve contacting your local building department or consulting with a qualified electrician. Compliance with electrical codes is not only a legal requirement, but it is also essential for ensuring the safety and reliability of your electrical system. Failure to comply with these codes can result in fines, delays, and even dangerous electrical conditions. When working with electrical systems, it's important to understand the concept of voltage drop. Voltage drop refers to the decrease in voltage that occurs as electricity travels through a wire. Excessive voltage drop can cause electrical equipment to malfunction or operate inefficiently. The amount of voltage drop depends on several factors, including the length of the wire, the size of the wire, and the amount of current flowing through the wire. In your case, you are running a 100 amp subpanel 200 feet from the main panel. This is a relatively long distance, so voltage drop could be a concern. To minimize voltage drop, it's important to use the correct size wire. The larger the wire, the less voltage drop there will be. The NEC provides tables that can be used to determine the appropriate wire size for a given application. Consult these tables to ensure that you are using the correct size wire for your project. Another important consideration when running conduit is the bending radius. The bending radius refers to the minimum radius to which a conduit can be bent without damaging it. Exceeding the bending radius can cause the conduit to kink or crack, which can compromise its structural integrity and make it difficult to pull wires through it. The NEC specifies the minimum bending radius for different types of conduit. When bending conduit, use a conduit bender that is designed for the type of conduit you are using. Follow the manufacturer's instructions carefully to ensure that you are bending the conduit to the correct radius. In addition to using the correct size wire and bending conduit properly, it's also important to use high-quality electrical connectors. Electrical connectors are used to join wires together and to connect wires to electrical equipment. Poor quality electrical connectors can corrode or loosen over time, which can lead to electrical problems. Use electrical connectors that are specifically designed for the type of wire you are using. Make sure that the connectors are properly sized for the wire and that they are installed correctly. When making connections, use a torque wrench to tighten the connectors to the manufacturer's specifications. Proper torque is essential for ensuring a secure and reliable connection. Grounding is another critical aspect of any electrical installation. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The NEC requires that all electrical equipment be properly grounded. When installing your subpanel, make sure that it is properly grounded. This typically involves connecting a grounding wire from the subpanel to the main panel. Consult the NEC for more information on grounding requirements. Surge protection is also an important consideration, especially in areas that are prone to lightning strikes. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can damage or destroy sensitive electronic equipment. SPD are typically installed at the main panel and at subpanels. Consider installing SPD at both your main panel and your subpanel to protect your electrical equipment from voltage surges. When running conduit along a stucco wall, it's important to secure it properly to prevent it from moving or sagging. Use conduit straps or clips to secure the conduit to the wall. Choose straps or clips that are designed for the type of conduit you are using. Space the straps or clips according to the manufacturer's instructions. In addition to securing the conduit to the wall, it's also important to protect it from physical damage. If the conduit is exposed to vehicular traffic or other potential hazards, consider installing a conduit guard. A conduit guard is a metal or plastic shield that protects the conduit from impact. Before backfilling any trenches or covering any conduit, it's important to inspect the installation thoroughly. Make sure that all connections are tight, that all conduit is properly supported, and that all grounding is in place. Correct any deficiencies before proceeding. Once the installation is complete, test the system to ensure that it is working properly. Use a multimeter to check the voltage at the subpanel. Verify that the voltage is within the acceptable range. Also, test the grounding system to ensure that it is functioning correctly. By following these guidelines, you can ensure that your 100 amp subpanel installation is safe, reliable, and code compliant. Remember to always prioritize safety and to consult with a qualified electrician if you have any questions or concerns. And here are a few more points to consider. When choosing between Schedule 40 and Schedule 80 polyvinyl chloride conduit, consider the environmental conditions to which the conduit will be exposed. If the conduit will be exposed to direct sunlight, Schedule 80 is the better choice, as it is more resistant to ultraviolet degradation. Also, if the conduit will be buried underground, Schedule 80 is recommended, as it is more resistant to crushing. When using polyvinyl chloride glue, be sure to use a glue that is specifically designed for polyvinyl chloride conduit. Other types of glue may not bond properly to the polyvinyl chloride, which can lead to leaks. Also, be sure to follow the manufacturer's instructions carefully when applying the glue. Over-application of glue can weaken the joint, while under-application can lead to leaks. When pulling number 2 wire through the conduit, use a wire-pulling lubricant to reduce friction. This will make it easier to pull the wire and will prevent damage to the insulation. Be sure to use a lubricant that is compatible with the type of wire you are using. Some lubricants can damage certain types of insulation. When connecting the number 2 wire to the terminals in the panel, be sure to use a torque wrench to tighten the terminals to the manufacturer's specifications. Over-tightening the terminals can damage the wire or the terminal, while under-tightening can lead to a loose connection. A loose connection can cause overheating and can even start a fire. When labeling the circuits in the subpanel, be sure to use a clear and durable labeling system. This will make it easier to identify the circuits in the future and will prevent confusion. A good labeling system should include the circuit number, the amperage of the circuit, and the type of load that the circuit serves. When creating the offset angle, precise measurements and careful planning are key. Before cutting any conduit, measure the distance from the existing panel to the subpanel and determine the desired offset. Use a conduit bender to create the necessary bends, ensuring that the bends are smooth and gradual. Avoid sharp bends, as these can restrict the flow of electricity. When using the angled conduit body, choose a conduit body that is appropriate for the size of the conduit and the angle of the bend. Conduit bodies are available in a variety of sizes and angles, so you should be able to find one that meets your needs. Be sure to install the conduit body securely and to seal it properly to prevent moisture from entering. When securing the conduit to the stucco wall, use fasteners that are specifically designed for use with stucco. Stucco is a brittle material, so it is important to use fasteners that will not crack or crumble the stucco. Also, be sure to use fasteners that are corrosion resistant, as stucco can be corrosive to some metals. When running the conduit parallel to the stucco, maintain a consistent distance between the conduit and the wall. This will create a clean and professional look. Use a level to ensure that the conduit is running straight and that it is not sagging. When connecting the conduit to the subpanel, use a conduit connector that is appropriate for the size of the conduit. Conduit connectors are available in a variety of materials, including metal and plastic. Choose a connector that is compatible with the type of conduit you are using. Be sure to install the connector securely and to seal it properly to prevent moisture from entering. When backfilling any trenches or covering any conduit, use a material that is free of sharp rocks or debris. Sharp rocks or debris can damage the conduit and can even cause it to leak. Also, be sure to compact the backfill material properly to prevent settling. When testing the system after installation, use a qualified electrician to perform the testing. A qualified electrician has the knowledge and experience to identify any potential problems and to correct them safely. The electrician should test the voltage, the grounding system, and the continuity of the circuits. The electrician should also inspect the installation to ensure that it is code compliant. Remember that working with electricity can be dangerous. Always follow all safety precautions and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure that your 100 amp subpanel installation is safe, reliable, and code compliant. And now, let's consider some troubleshooting tips for common problems that may arise during or after the installation. If you are having difficulty pulling the number 2 wire through the conduit, check for any obstructions in the conduit. Use a fish tape to clear any obstructions. Also, make sure that you are using a wire pulling lubricant. If the voltage at the subpanel is too low, check the voltage at the main panel. If the voltage at the main panel is also low, there may be a problem with the utility company's service. If the voltage at the main panel is normal, check the wire size between the main panel and the subpanel. If the wire is too small, it may be causing excessive voltage drop. If the grounding system is not functioning properly, check the grounding connections at the main panel and at the subpanel. Make sure that all connections are tight and that the grounding wires are properly sized. If a circuit breaker trips frequently, check the circuit for overloaded circuits. Remove some of the loads from the circuit or add a new circuit to handle the additional load. If a circuit breaker trips immediately after being reset, there may be a short circuit in the wiring. Disconnect all of the loads from the circuit and then reset the circuit breaker. If the circuit breaker trips again, there is a short circuit in the wiring that needs to be located and repaired. If you are experiencing any other electrical problems, consult with a qualified electrician. A qualified electrician has the knowledge and experience to diagnose and repair any electrical problems safely and effectively. And finally, here are some tips for maintaining your electrical system after the installation is complete. Inspect your electrical system regularly for any signs of damage or wear. Check for loose connections, frayed wires, and cracked conduit. Repair any problems immediately. Keep your electrical panels clean and free of dust and debris. Dust and debris can accumulate on the electrical components and can cause them to overheat. Test your ground fault circuit interrupters, or GFCIs, regularly to ensure that they are functioning properly. GFCIs are designed to protect people from electrical shock. Replace any worn or damaged electrical components immediately. Worn or damaged electrical components can be a safety hazard. Consult with a qualified electrician if you have any questions or concerns about your electrical system. A qualified electrician can provide you with valuable advice and can help you to keep your electrical system safe and reliable. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always follow all safety precautions and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure that your electrical system is safe, reliable, and code compliant. And remember, the techniques described are meant to provide general guidance and should not be considered a substitute for professional electrical advice. Local codes and regulations can vary significantly, so always check with your local authorities or a licensed electrician to ensure compliance with all applicable requirements. When working with electricity, safety should always be your top priority. Double-check all connections, use appropriate safety equipment, and never work on live circuits. If you are not comfortable performing any of these tasks, it is best to hire a qualified electrician. Taking the time to plan your project carefully and follow best practices will help ensure successful and safe electrical installation.